Hello world, Joshua here at JTC Education, and today we're going to look at one of my favourite maths problems of all time. It's the 100 coin problem. So I simply love this maths problem. For me, it's what maths is all about. Even with the tender age of 11, you have enough maths knowledge to solve it fully. But it requires a good amount of lateral thinking and a strong ability to problem solve. Let's see if you can solve it. So first of all, we need to define the problem, and it goes something like this. I have 100 coins all in a line, all heads up. And so what I do is I turn over every single coin. If I turn over every single coin, they are now all tails up. I go back to the beginning of the line and I turn over every other coin. In other words, coin 2, coin 4, coin 6, etc, 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 all the way up to coin 100. Following so far, there are now 50 coins that are tails up. Now here's where it starts to get a little bit more complicated. I go back to the beginning and I turn over every third coin. So coin 3, coin 6, coin 9, etc, 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 all the way up to coin 99. And then I go back to the very beginning again and I turn over every fourth coin. Then I go back to the beginning again and I turn over every fifth coin, etc, 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 until finally I am turning over every 99th coin. And just to clarify, that means I will only be turning over the 99th coin. And then I turn over the 100th coin and I have finished the process. And the question is very, very simple. How many coins are tails up at the end of this process? So of course we could solve this problem by brute force, but that's not the point. There is a very neat, very smart solution to this, and it requires no more than the maths knowledge of an 11-year-old. Now in a moment I'm going to start feeding some clues as to how to solve the problem, but I don't want to steal all the fun. So if you want to have a go at trying to solve this yourself first, and I recommend that you do, pause the video in 3, 2, 1, now. Not that easy, right? Don't worry, here comes clue number 1. Pick a coin, any coin. Yes, very often when people try to solve this problem, they will go through in the order that the question suggests. So they'll turn over every coin in their heads, and that's easy peasy, everything's tails up. Then they'll turn over every other coin, no problem. Half of them are tails up, 50 coins are tails up. Then they'll try and do every third coin. They might manage, but it's getting a little bit more tricky, and by the time that we're at the fourth coin, it's a headache. So why not generalize this and simply pick a coin, for example coin number 10, and ask whether coin number 10 will be heads up or tails up after the 100th turn. And also try and ask yourselves why that is. So I suggest that everybody takes my clue of pick a coin, any coin, and has a go at solving again. And don't worry if you can't get there, because in a moment I'll feed a clue number 2. If you want to have a go at that, pause the video in 3, 2, 1, now. Feeling like you're almost there but can't quite get to the solution? Welcome to the joy of maths. Here comes clue number 2. Try to think about what decides how many times a specific coin flips. Let's take coin number 10 again, and try to think about what property of the number 10 decides how many times it flips after carrying out this whole process. And so as ever, I encourage everybody to stop the video and have another think about the problem by themselves. If you'd like to do that, pause the video in 3, 2, 1, now. Feeling like you're so close and yet it keeps slipping through your fingers? That's what real maths is like. Okay, here comes the third and final clue. What is the difference between coin 15 and coin 16? The reason I picked these two coins is one of them ends heads up and one of them ends tails up. Try and think about why that is, and you might be able to solve this problem. And so as ever, I encourage everybody to pause the video and have a think about it by themselves in 3, 2, 1, now. Alrighty, enough clues, time to put everybody out of their misery. Here comes the solution. So following my clue number 1, I am going to pick a specific coin, coin 10, and I'm going to ask myself, when does coin 10 flip? Well, it turns over on the first time through because every single coin turns over on the first time through. Does it turn over on every other coin? Yeah, it does, because 2, 4, 6, 8, 10 will flip. Does it turn over on the third time through? No. 10 doesn't turn over on the third time through. Why? Because 3 is not a factor of 10. Haha, we're already on to something. So coin 10 will simply flip on the first, second, fifth, and 10th time through. After the 10th time, we're past coin 10 anyway. So that is 4 times, and if coin 10 flips 4 times, it will return to heads, because of course if we flip a coin an even number of times, it returns to where it started. Okay, and so finally the question is, which coin is going to flip an even number of times, i.e. have an even amount of factors, and which coins are going to flip an odd number of times, i.e. have an odd number of factors? If you'd like to have a little think about that, pause the video in 3, 2, 1, and now. It's the square numbers, of course. Factors always come in pairs. Let's look at coin 10. 1 times 10 equals 10. 2 times 5 equals 10. The only numbers in which factors do not appear as pairs is square numbers. For example, 16. 16 has the factors 1 and 16, 2 and 8, and 4 is just by itself, and therefore it has an odd number of factors. And so very simply the problem becomes, how many square numbers are there between 1 and 100? Every single square number will turn over an odd number of times and therefore land on tails. There are 10 square numbers between 1 and 100, and therefore the final answer to this question is 10 coins will be tails up. Isn't that just an awesome maths problem? When you think of it one way, it seems impossibly complicated. But then when you generalize it and try and approach it coin by coin, it's as simple as square numbers, factors, and odd and even. And that's why it's Joshua's favorite maths problem.